Sure. Good. All right. We are live right now. Thank you very, very much. Good afternoon. We were talking a little bit earlier, depending on where you are in the world. Good morning, good evening, whatever you want. Today we are joined by Enrico, who is located in Italy, in the north, in what is somewhat considered to be the gelato capital of the world, a city called Rimini. You definitely need to check it out. His wife works in a trade show that is attended by 200,000 people on a yearly basis. That is normally held, I believe, in January. Anyway, Enrico, very, very good to have you with us here today. We'll try not to talk too much about gelato. We're here to talk about some other things. Very nice to have you. Could you just give us a brief introduction about who you are
Sure.
and what we're going to be talking about today?
Well, first of all, thank you for having me. And as you said, I live in Rimini, so it's a small town, 200 kilometers south of Venice, and I'm a Gigaom analyst for data storage. And this is probably why I am here today. In general, you can think of me about a long-time practitioner that moved to a different role lately because it was interesting to see things from the other side of the fence and not just doing them. And I started with a blog many years ago now, and it evolved in time. And then somebody asked me to be more formal, so less informal than a blogger, and I started to do this. So data storage is my passion. I started working in data storage in the early 90s. So I developed a lot of connection in the industry with both users as well as vendors. And I think it's pretty much it.
Okay, good. Well, that being said, we can just jump right ahead into your presentation. As always, feel free for folks in the audience to put your questions in the comments in the chat section in YouTube. If we don't get to any of the questions, we can always continue the conversation later on today or this week or next week as well in Slack. So that being said, Enrico, it's all yours.
Okay, fantastic. Thank you very much. So just a quick look at the agenda. First of all, we will have an introduction about storage for Kubernetes. Then we will do a short comparison about Kubernetes native solution against enterprise solution, traditional solution that has CSI compatibility, important evaluation metrics to look at when you make these kind of choices, the key criteria for evaluating data storage for Kubernetes, and we also we will have a look on emerging technology to consider for the medium long run, and last but not least, a short market landscape analysis. So all of this content comes from one of my reports that has been published a few weeks ago, so it's new stuff, and it comes from a long research that we conducted with all the vendors that are in this space. So I want to start by sharing with you a question, and we will share the results of these polls at the end. So what is your current storage for Kubernetes? And you can pick one of those. So I don't have one yet. It's deployed in the cloud. So there are cloud resources from the cloud provider, a traditional storage with CSI, open source, a free Kubernetes native solution, or a commercial Kubernetes native solution. So please answer. This will help us to understand better the audience, but also will help in the end to have a better discussion.
Good. So just so everyone knows, I put the link to the question in the chat, so you just got to click on that and you can answer that there, and I'll do that with the following questions as well, because there will be some other questions later on.
Okay, fantastic. So without any further ado, what is CSI? So Kubernetes Storage Interface, container storage interface. And so usually when we talk about storage for Kubernetes, we think about CSI as the standard now, but we went through a lot of iteration before. So some very proprietary stuff, and then we had some initiatives that didn't go very well. Finally, we had this CSI, and this is not the only interface. So the CSI interface is something that abstracts physical storage from the container layer, and it implies that as an abstraction, you have APIs to interact with storage to provide resources that are necessary to your system. CSI is evolving quickly. Every few months we have additions. So we have physical volumes that are now available. There are mechanisms for the snapshot. Unfortunately, not all the features that we are used to see in enterprise storage are available in CSI yet. So there are a few issues when you look at how to build your storage infrastructure for Kubernetes that we have to take into account. So the most common deployment model for CSI is to have a plugin in each of the host node or in each of the worker nodes, and in the master nodes we have a controller plugin. Okay, sometimes it's a little bit more complex than that. There are sidecars that help with special functions, but actually this is just to simplify this introduction. And so what is the difference between containers and VMs when it comes to storage? And I want to show you this. Many of you probably already know this, but it's very important to understand what happens at the storage layers. Okay, and of course you have the application layout. Usually when we talk about VMs, virtual machines, you have one or few virtual machines that do everything, while on Kubernetes you have many containers because the application is divided in microservices. The rate of change of this virtual machine is very low, so that it's a static environment. You don't have a lot of machine popping up when the needs arise. Everything is not so automatic, while on Kubernetes the environment is very dynamic. Of course, the application that we have on a virtual machine is stateful for a lot of reasons, while in Kubernetes we have a lot of stateless containers and some stateful data volumes that are accessed by some containers. This means also that the application status in a traditional environment is incorporated in a VM. This is also why I said that the application is always stateful in a VMware environment, okay, in a virtualized environment in general. While in Kubernetes, we have some components, some parts of the application that are managed by external resources, for example, HCD, and that as...
Oh, sorry.
What?
Someone in the YouTube chat from Yasulas, thank you for the question. He's asking, would it support VMware CSI?
Sorry, say it again?
Would it support VMware CSI? Yasulas, we may have to ask you for a little bit more context, but if that makes sense.
Well, no, but maybe so. VMware CSI is one of the many implementations, and usually is used with the Tanzu, which is their platform for Kubernetes. So it's when we talk about VMs in this case, is to make a comparison between a traditional environment and a container-based environment. So we are not yet at the point where we do a comparison about different implementation of CSI of different stacks. So I think that maybe the question is too generic at the moment, but if the idea is to ask about if the VMs use CSI, no, this is not the case. And just to close with this slide, usually you have very few volumes attached to the VMs, while for containers you can have many different volumes that are accessed by the application by these containers. So the environments are totally different. And there is another important aspect to look when we want to implement an infrastructure, storage infrastructure for Kubernetes. Okay, maybe today we are on the left of this slide, so where we have on-premises Kubernetes, and we are selecting a storage for Kubernetes. But you know, a lot of users deploy Kubernetes directly in the cloud, and you want to use maybe the resources provided by the cloud provider, or in other cases it's a managed Kubernetes, so it's not something that you manage, but all the infrastructure like EKS or GKS or one of these many acronyms. That means that Kubernetes is managed by the provider, and they provide additional storage resources. What you want actually is not to use a different storage for each one of these, because you want to leave the promise of Kubernetes that to port your application where you need it. Okay, even if you start today with on-premises and you want to go to the cloud, and then you want to go to a managed Kubernetes, then you want to have your data with your application. To have it, you need the same identical storage infrastructure, because you don't want to spend too much time, for example, waiting to copy your data to another environment. So you want automations that do it for you. And it's also true for other aspects, including disaster recovery and so on. That everything that we will touch later in this presentation. So what are the differences between a Kubernetes native storage and an enterprise storage? Okay, with CSI compatibility. So an enterprise storage that is compatible with Kubernetes. Okay, if we look at the enterprise storage, probably you already have it. I mean, it's in your data center, so you download the CSI plugin. It's available. Most of the vendors already have them. Not all of them are really up to the latest CSI specifications, but actually it's already there. So it's something that you can use already. The user interface is quite familiar. I mean, the same storage interface that you already had in the past. You configure a few things and it's ready to go. It's unfortunately it doesn't scale. We will touch this in the key criteria section. But for most of the enterprise solution that we have in our data center, when we think about Kubernetes, they are not ready to scale at the Kubernetes pace. And another thing about enterprise storage is that it is really efficient. I mean, everything has been designed with data services in mind. So you have thin provisioning, you have the duplication, compression, and snapshot and remote replication, etc., etc. So everything is there. Not everything is well implemented when we talk about Kubernetes, but actually is already there. And last but not least, and this is important, it's very difficult to have hybrid deployments, and we will touch again on this later. So it's a physical device. Do you have a physical device from your cloud provider? Maybe not. Maybe you have something else, but actually it's not the same thing. So, and last but not least, this is CSI compatible. So it gives the basic functionality, just it. We will see later that there are other functionalities that some vendors are adding on top of CSI or in parallel to a CSI to make things better. So when we are talking about Kubernetes native, there is a huge difference. The first is you have to acquire new resources. No matter if it's an open source or if it's a commercial solution, you have to acquire the software, you have to acquire the resources that could be serviced with hard disks or flash memory, but there are some hardware that you have to acquire. So the process is a little bit longer. Not for everybody it's so easy to purchase new hardware without a long list of actions and so. The interface is probably new. Okay, this is not really difficult. I mean, all this Kubernetes native software can be controlled via APIs. They have a nice interface, not all of them, and command line interface is pretty intuitive in most of the cases. But again, it's a new interface. It's something that it's not for everybody. Okay, especially if you are working in an environment where the DevOps team doesn't have the full control of the infrastructure, and this is it happens very often in large organizations where you have still traditional operation having control of the hardware underneath. And the main difference is that Kubernetes storage is very scalable compared to enterprise, and I will talk about this again in depth later. And efficiency, so and so. I mean, some of these solutions can implement the duplication, can implement compression, provisioning, etc., etc. But we are far from the efficiency of an enterprise storage system. And okay for hybrid multi-cloud, meaning that you can deploy the same identical solution because it's deployed in a container format. In the end, you can deploy it wherever you want, and it runs in Kubernetes. And of course, there is it goes beyond CSI. As I already mentioned, there are some features that are not implemented in the CSI yet, or they are not fully available. But for this solution, so for these vendors, storage vendors, are things that are already there that you can use. So let's talk about the evaluation metrics. I usually think about evaluation metrics when you evaluate a new technology as very high level features or very high level characteristics that you want to see. Think about a car. Okay, when you go to the car resellers, what you want to see, what you want to talk about is comfort or performance or in general safety. Okay, so these are high level metrics. Okay, but then you look at you make your decision on the details. So, and these are the key criteria in my report. So for example, if you are looking at a new car today, you're looking for safety, and maybe one key criteria for safety today could be an electric engine. That is also important for performance and maybe for other metrics of the car. So when we evaluate storage for Kubernetes, there are a lot of metrics. Architecture is very fundamental today. Most of these solutions are really new. Some of them have architecture that are simple. Doesn't mean that it's bad or good, but simple also means that if you look into them, they are not ready to scale, or they are not implemented yet in a way that will allow you to build a large infrastructure at a global scale. I'm saying that because, for example, to simplify the development process, most of these solutions are based on file system, for example. Even if you are deploying block storage, they tend to rely on a file system. It's a good choice for some smaller environment or medium-sized environment. But actually, if you think about at large scale, you have another component to deal with, which is the file system on which your blocks are stored. And it could be, easier at the beginning, but in the long term could become more complicated to manage a solution like this in terms, for example, about tweaking the performance, optimizations, and so on. Another important aspect, as we said, is scalability. Okay, when we talk about scalability, we talk about moving your infrastructure from a bunch of worker nodes to hundreds maybe, and you want to be sure that everything scales, especially when it comes to not only IOPS, so not only the operations that the system can provide on the physical disk, but actually on everything that you manage. So including analytics, including manageability of the system, and so on. And another aspect is flexibility. As we said, there are systems that are usually deployed on premises only. There are others that are a little bit more sophisticated. You can have, a deployment also in the cloud, but others can give you many more options and many more possibilities for the future. So flexibility probably is one of the most important here at the moment, looking at most of my clients. Efficiency is another point. Even if you start today with a small installations with a few terabytes of storage, and you don't think it will become a huge problem in the short term. In the long term, efficiency is very important. It could impact your TCO, infrastructure TCO. So efficiency is something that you need to look at the very beginning. So you don't avoid to get what you already have from enterprise storage. Also in Kubernetes native, there are some features that are not ready yet, but all the vendors are trying to make their solution more efficient. And of course, manageability and ease of use. And here I talk about, yes, everybody in this environment talks via APIs or command line interface. A nice user interface is necessary for the operations team in your organization. They want to keep things simple. They want to have a data center mine case, use the system in many ways to make standard processes that can be followed by everybody. So think about also these things when you start deploying a new infrastructure. So with this in mind, so with the high level metrics to make this kind of decision, let's talk about the key criteria. What you should look in detail to find the best solution. So one of the first thing that is really important is advanced data services. There are some solutions that allow you to go beyond snapshot. Okay, if you think about basic data services, spin provisioning, snapshot, and things like that, one very important thing is having synchronous data replication. So having the possibility to move your data synchronously between clusters that are close by, or regions in availability zone in a cloud provider. So you can have a higher availability from your system. Of course, synchronous can be applied only when the two systems are close to each other. So another important feature is to look is asynchronous data replication. And this is important for other aspects. So having a copying of your data on a different region of a cloud, or having a hybrid installation where you can have an on-premises cluster in production and a second copy ready for disaster recovery in the cloud, or vice versa, or making copies of your data for other purposes, for example. So this is a way to implement. Of course, there are other advanced data services. Some solutions integrate a backup functionality, and in other cases you need a mechanism. Okay, actually not in other cases, sorry. In most of the cases you need mechanism to synchronize all the snapshots. So there is no concept in CSI yet of the consistency group. That is, a way to put all the volumes in a consistent state before taking a snapshot. Okay, so that you flush your data from RAM before taking a snapshot. Some vendors are more advanced than others in this scenario, and they can do this. So this is another important step to take your services at the right level for enterprise grade services kind of approach. And as I said earlier, okay, if you think about your on-premises storage and you think about traditional storage in the cloud, there are some options. Okay, so it's true that most of the time you can't have a real physical storage system in the cloud. Actually, there are some vendors that do it, but it's very expensive and it's not very flexible. Some vendors offer an approach that is quite simple. So they provide a service that has some similarities with their on-premises storage, so you can use the same mechanism, for example, for asynchronous data replications. Okay, or they provide you a virtual appliance that you can install in one EC2 instance, for example. Okay, and there are, as I said, a third option with some vendors provided providing physical storage attached to the cloud provider data center. So you actually renting part of this physical storage. Usually is the less flexible way to do it, but it's possible in some cases. So these are all things that you have to check when it comes to data services. It's really important, it's really critical to get disaster recovery done, having a backup done, integrated with a solution, which is another important aspect if you want to keep costs down. And then there is performance. Okay, we talked about performance. I mentioned performance several times. You have to think about performance, not about IOPS and throughput. I mean, everybody can do IOPS and throughput today. You just throw more resources to the system and probably you can get it, because there are no longer bottlenecks. Okay, and take this with a grain of salt. Of course, I'm simplifying here, but the idea is that we have NVMe storage, we have all the flash memory types. We can do performance. Okay, what we can't do is provide resources to Kubernetes containers in quickly. So some systems don't have, first of all, a CSI plugin that is mature enough. This is not optimized enough to provide new resources at a very quick rate. So that could be the first problem. The other thing that always happens is that your traditional storage system is not designed to provide hundreds of volumes in a matter of a meeting, and so they are designed to provide less volumes in a very long period of time. So this could be very challenging, especially because with some application you can have volumes that disappear after a few minutes. So you create volume, you do what you have to do, and then the volumes is killed alongside the container. This can happen very often, and not all the systems are designed to cope with all this allocation and deallocation of resources. Another big issue with performance is resource orchestration. Not all the vendors today offer the ability, if you have a fleet of storage arrays, to allocate some space for Kubernetes in each single array and then orchestrate the resources in terms of what is the best array for this workload, what is the best, where do I have capacity, where do you have more IOPS available, and things like that. So this is not for everybody, and in some cases could become an issue if you need a lot of resources in a limited amount of time. And as I mentioned, the storage system control plane. So I already talked about this. It's about how fast you can provide new resources, how fast you can deallocate them. So next point, optimization. Why optimization? Because optimization maybe in some environments is not important today, okay, because the environment is still small, but it's growing quickly. Okay, so all the optimization that we saw over the years implemented in enterprise storage arrays will become important very quickly. Even if the vendor does not have it now, you have always to look if there are mechanisms to implement it. If there are, some of these mechanisms already implemented, that means that they thought about it, and you can have it implemented in a near future when demand will arise. Consider that, as I said, layered solution. So when you have Kubernetes storage on top of a file system, for example, and some of these optimization techniques are delegated to lower layers in the stack, it could work, but it also means that the storage vendors doesn't have full control of the entire stack. It could be, a simpler solution. It could be also a cheaper solution. It's not always the best solution. Actually, in many cases could be very punitive in for heavy workloads when you have to do a lot of allocation of resources and deal with optimization at the same time. Multi-tenancy, and as you know, with Kubernetes, multi-tenancy is fundamental in several aspects. For storage is even more important. There are a few things that are implemented in storage. One is storage classes. You have to check if storage classes really work. And I'm not saying this because some vendors don't implement the storage classes, but because you want to be sure that when you ask a type of resource, you're sure that you get this type of resource and it's implemented correctly in the backend. So the right resource is provided, it works like you think, and everything is aligned with the expectation from the application. There is another aspect which is also very important, is quality of service, okay, which is related to storage classes, but it's a little bit different, because when you ask a resource providing a specific storage class, you take some resources from a pool, okay, but if you allocate too many of the same kind of resource, maybe you have some contention. Okay, quality of service is important to avoid this contention. So even if you start from the same pool of resources, you have some applications that are more important than others. And when you start to allocate a lot of containers and deallocate them in a quick pace, then you want to be sure that all these rules will be maintained over time. And of course, last but not least, there is another important aspect, which is I called it organizational multi-tenancy. So it's not only at the Kubernetes level, but actually at all the level of the stack. So of course there is role-based access control, which is an important part that is important to manage your system. But actually there are a few other components at the in the storage backend, especially when we talk about the storage infrastructure that is not managed by the DevOps team. Okay, so you are asking new resources from Kubernetes, but in the backend there is an infrastructure that is managed probably by a different team. So you want some self-service, and at the same time the operations team want to keep control on what the guys at the Kubernetes level are doing. So this is very complicated, and it is a concern in many organizations. So having it implemented by the system, so giving flexibility, but it's at the same time observability of what is happening in the system is very important. And also this includes also some chargeback or maybe more showback kind of functionality. Security is important for everybody and everyone, even if we are not experiencing yet the same level of security issues that we have with other storage systems, like ransomware is not yet very prevalent in Kubernetes like it could be in other environments, okay, but it's only a question of time before we will reach that kind of level. It's mostly because adoption, and but we want to start, and of course having encryption. So encryption is important for several reasons. Yes, I took it ransomware, but this is just the tip of the iceberg. It is the most common threat that you can read on everywhere. But actually you want everything encrypted also, because when you talk about Kubernetes storage, you are encrypting data today on premises, and tomorrow when you go to the cloud with the same application and the same data, you want to be sure that everything is encrypted, especially if the cloud is not managed by you. So it's not an hosted solution, but it's a managed solution. So you want to keep, a level of security across all your infrastructure that is similar. And so encryption is a very important key feature of your Kubernetes storage. And of course with it, comes all the key management, which is a very important aspect of encryption. And as I said, all the storage solution you are implementing today should be compliant with role-based access mechanisms that are provided by Kubernetes. It's becoming table stakes here, so it's everybody is implementing it in the right way. But actually, give it a quick check, because still today there are a couple of solutions that are not yet there. One, and probably this is the last very important point, is monitor and analytics. Okay, we have analytics and monitoring storage since forever. Okay, it improved a lot. We have AI techniques now involved to get a clear view of what is happening, what is going to happen if the trends are what we are experiencing today, and things like that. So there is a lot of proactive actions that the system can do for you, like even open a ticket if something goes wrong with a disk or with a flash device. So that's it really simplifies the mechanism. The problem is today that not all the solutions are porting these functionalities to Kubernetes. Okay, and with this I mean, of course, you are deploying a storage for Kubernetes, and you want to have full visibility on the Kubernetes environment as a whole, but also on what each single application does, how your resources for Kubernetes are allocated and how they are working, and so on. So this is a very important aspect, especially because we want to understand when it's time to do new purchases of hardware, or for capacity planning in general, resource planning in general. And today is very difficult because most of the solution, especially the traditional enterprise solution, do not implement mechanism to get a full view of the single application or the full view of all the containers allocated. They see the volumes as LANs in the backend, and that's it. So making it very difficult for the sysadmin or for the DevOps team to understand what is really happening at the application level for their Kubernetes environment when it comes to storage. So I have another question for you, and maybe Bart, you want to share the link. So what is the most important criteria for you after this presentation? So advanced data services, everything related to advanced snapshot, consistency group, replication to remote infrastructure, performance and optimization. I put them together because they go alongside each other. Optimization, oops, I made a mistake here. Multitenancy, and monitor and analytics. So
yep, the question.
Security
the question
optimization was security. Sorry, but
that's okay. That's okay. No worries. The question's in the chat, so people can answer that way.
So let's go to the next part of the presentation then. So, which is emerging technology. What is happening at the storage level for Kubernetes when we talk about enterprises? Okay, one thing that it's important today, and many organizations are talking about, is edge use cases. Okay, edge use cases meaning having very small cluster deploying one or two applications at the far edge, and sometimes we are talking about telco towers, so very small environment. So most of the solutions that we have today are not yet optimized for these edge use cases. So if you're thinking about building something in this regard, so your edge infrastructure, and you are going to deploy Kubernetes in remote location, and you want a storage that is manageable from a single console, a centralized console, and having information of these storage systems and deploy them in very tiny environments and things like that. This is very important. This is the time to start thinking about it. Not all the solutions are ready for this, very few actually, but it's a concern for some organizations, especially very large organizations. So we will see more and more of this in the next 12-18 months. And another important initiative is COSI. So it's like CSI but for object storage. Okay, and you will see that more solutions will implement a COSI plugin. So traditional object stores are already moving to containerize themselves, becoming more Kubernetes friendly. There are some solutions that are already fully containerized and they can provide this kind of solution. COSI is not yet there, but it is a new specification with a lot of interest from vendors and of course from users. There is a lot of demand, and of course you will find, as we saw in the past, okay, so the unification of files and blocks for primary storage. Then we will add also object storage for these storage technologies, and maybe this could happen additional use cases. And with this, I want just to give you again a view on the iteration between the metrics and the key criteria that we have analyzed. When I prepare my reports, of course I put together all this information and I try to give to the reader something that is aligned to the general audience, okay, to the enterprise. But actually, for example, if you look at the various key criteria that we analyze and the metrics, you could have some differences. I mean, for example, for you, monitoring and analytics could be less important when it comes to manageability of ease of use than what I thought. This comes from interviews that we had with enterprise end users. But again, you could be in a vertical, you could be in a different scenario where you have different needs. So what I said is true in general, but not for the single use case sometimes. And this is at the base of the next section. So how do we build our market landscapes? So our market landscape for Kubernetes native storage looked like this. Okay, you have a bunch of vendors. Some of them are running very fast, like Robin.io, Portworx, Diamanti, NetApp, Red Hat. Okay, but not all of them are general platform players. I mean, platform players in the case means that they can play with different Kubernetes, they can play on different environments, and they can do they can support you in multiple types of environments. Okay, others are more specific to a single environment. For example, VMware has a solution for Kubernetes storage, but actually it is designed to work only with VMware. We are not saying that is a bad solution. In fact, they are close to the central circle where we have the leaders, but actually it's designed only for this solution, as well as for Red Hat and NetApp, for example. Okay, while other like Portworx or Robin.io, they are focused on serving a larger number of use cases. As you can see, there is a lot of innovation going on. So all the vendors in this area are in the innovation quadrant of this chart, because all of them are adding features very quickly, and we don't have forward movers, which are our slow movers in this area. So everybody is moving very quickly. They are adding features. Some of them are more focused on an area, others are more platforms, but that's to give you that there is a lot of movement in the market. Actually, for the we can say the same for the traditional storage vendors. Some of them are still very interesting, and you can see that vendors like Pure Storage and NetApp, they have the same solution for both their traditional storage as well as the Kubernetes native storage. Pure Storage acquired Portworx not long ago, so this is why you saw Portworx in the other in the other radar, and here you see Pure Storage. But actually there are some vendors that are doing pretty well from this point of view, while others are catching up with features. So and a few of them have a basic CSI implementation. Nothing bad with it. I mean, maybe it's just because their customers are not yet ready to implement Kubernetes at scale, but this is something that you have to check if you want to implement Kubernetes with one of these vendors. So that said, as I said, very few vendors are interpreting it right at the moment when it comes to Kubernetes storage. So I'm open now for all the questions, and maybe we can review what we learned from the audience.
Okay, good. Slack. So the first one, touching on monitoring. When you let's see, so where are you go? From a monitoring standpoint, which metrics should we care most about when thinking about storage? Should we really alert of memory capacity if we have auto scaling enabled, for example?
No. So when we talk about storage, usually you think about latency to access the data and IOPS. Okay, these are the two most important. Of course, also throughput, depending on the kind of workload. But let's concentrate for a second on IOPS and latency. And you want to have them consistent. Okay, you don't want spikes. You don't want drops or things like that. And so the problem today is that even if you have a Prometheus exporter, so you have to aggregate all the information from all the volumes, and this gets even more complicated if your application is distributed on top of several storage arrays. This is why I talked about an orchestrator. So you get the full picture of the volume, and then you get all the data from the storage system, and you move it to the to maybe Prometheus or a tool provided by the vendor. It's very few are implementing it right at the moment because you want to know everything. I mean, the latency that the application sees first, but then you want to see what happens in the backend as well. I mean, so having a full picture is still something that very few do.
Okay. Next question. Do you have any insights? Well, because some of the questions you were asking as well, too, I think might relate to this. Any insights on industry adoption of Kubernetes as of 2021? How quickly will the trend grow in your opinion? And is there any container orchestration system that might beat Kubernetes?
Okay, so the question is very long. So
sorry,
adoption rate of Kubernetes.
We can start. We can go by in pieces. So the first one regarding industry adoption of Kubernetes in 2021. What do you see? What are the challenges that organizations are still having to get into Kubernetes? And then further from that, when we're talking about storage, data, etc.
So the adoption is there now. So we moved. We are past to the first POC, first evaluation period, first application in many cases. Okay, so people are starting to deploy in production. Then the size of the Kubernetes environment in the infrastructure is something different. Okay, so if you look at a small organization, Kubernetes is not there. If you're looking, small enterprise organization. I'm not talking about a startup. Building a new application. That's a different. So if you're talking about a traditional, let's say, manufacturing company, or so a small organization really don't know what Kubernetes is. They don't really care. They are moving to the cloud, but it's more about adopting the cloud as a SaaS thing. So not a lot of customized application porting. If we look at large organization, including finance, banks, manufacturing, okay, where there are resources, then it's massive. There are a lot of initiatives to rebuild the application, move the application. I talked to a larger organization here in Italy a couple of weeks ago, and they moved from 0 to 20,000 cores for their Kubernetes environment in the last 2 years. Okay. And they are planning to move several other applications and moving to 80,000 core for the end of 2022. Okay. Yeah. So this is, accelerating very, very quickly. And in fact, we were there talking about storage issues, storage challenges everywhere. Okay. Because they want to do it in an hybrid way. So they have their data center, they have their operation team, and they want to leverage the cloud. They want to keep disaster recovery procedures that are already in place, also for this application, etc., etc., etc. So that's the kind of challenges. So Kubernetes is there. Many more users are adopting it. They are doing it seriously. Actually, there is a lack of skills and sometimes.
Oh, that's a classic thing as well. Like you said, one thing is the technology. The other thing is, are there enough practitioners who have experience? Which is partially why our community exists, so that knowledge can be circulated. And that's a really good point.
So there was another part of this question.
Yes, there is. Yeah. So I think you covered the part about the trend. Is there any container orchestration system that might beat Kubernetes in the next few years? That was a follow-up.
No, I don't think there is anything in my radar at the moment. I mean,
yeah,
Kubernetes already won. Maybe there will be the next Kubernetes, but we are not there yet. I mean,
yeah, for the time being, that's the thing. People are still adopting and getting used to this. So to put something else out there, I think might just get overwhelming. All right. Another question that we had from someone in our community. Let's see. So is storage in Kubernetes highly available? And if so, is it highly available by default?
Yes and no. I mean, if you're looking at an enterprise solution, yes. Okay. So usually enterprise solution adopted by enterprise are highly available, very resilient and things. You can have storage for Kubernetes. There are some solutions where you can turn it off. Okay. So, and because for some workloads, especially in HPC, AI, big data, where you have data sets, large data set that are stored in maybe object store or large files, file servers, NAS, or file system in general, and then you need to create, let's say, ephemeral volumes, okay, that need to stay alive for a few minutes, for a few hours, or maybe one day during your compute task. Then you can remove all this high availability thing because you can recreate the environment very quickly, and losing data is not your major concern, while speed and cost maybe are more important for you. So it's possible. Most of the solution can allow you to do that. The most enterprise one, not really.
All right. Okay.
But because it's not something that enterprise customer ask.
All right. For those new to storage in Kubernetes, could you explain the difference between static and dynamic provisioning?
Yes, it's quite simple. I mean, it's static provisioning and dynamic provisioning are actually two ways to provide storage to Kubernetes, and the dynamic provisioning is a mechanism for which you have a vast pool of resources and you can allocate and allocate storage very quickly. Usually, I think most of the time you have dynamic provisioning with a file platform in the backend, so that it's way easier to allocate resources without allocating the backend all the resources at once. So when you allocate the first resource, like a LAN, then you allocate immediately the resource in a static way to the container. While if you do allocate storage with a dynamic provisioning mechanism, you can have a simpler way to allocate and allocate resources in backend.
Okay, I'm gonna put a list here. Well, I'll send it to you here in the Zoom chat, and then I'll put it also on YouTube. Someone was asking, got a list of all the different storage plugins, and wanted to ask you about which one, if you had any favorites and why, or ones that you've worked with more and that you might have more experience with. Taking a look at that really quickly. I'll put this also here in the YouTube link. There are lots.
So the problem is not about what is my favorite plugin, because the plugin is about the storage that there is in the backend. So the question should be, what is my favorite in backend for this CSI plugin? So you install the plugin because you have the storage. I mean, there are a couple of differences here. So you have block, you have cloud, and you have solution that you install on premises, for example. So actually, I think that, for example, if you look at Storage OS, just to read one, you can use it only with Storage OS. So do you like Storage OS? Yes, it's a good solution. The same goes for OpenEBS. You can't use OpenEBS with something else. So it's not. It really depends on the use case. So I don't want to go onto the list and say this is better than the other, because most of the actually some of them are not even more. I don't even know, for example, Flocker is still a thing, but let's say that in general, you don't you choose the storage solution, and the CSI is the driver for that storage solution. So that's it.
Yeah. Okay. And
if you look at my radars, there are leaders, and these are my favorite solutions. I mean, what we evaluated as Gigaom as the best solution in the market at the moment.
Mm-hmm. Okay, and related to that as well too, regarding best solutions and what's on your radar, you're obviously a person, I ask this question in most of our meetups, you're obviously a person who reads a lot, who interacts with a lot of resources. And, there's not one magic solution. I think it's, something even we talked about in yesterday's meetup. There's not, one perfect video or one perfect book, but you as a person who has a lot of experience working in this field, what are your habits for learning? How do you stay in touch with the new things that are going on? What recommendations might you to give to folks, once again, because you said there's a big skill gap here. So what are the ways in your experience that have worked for you to sort of narrow that gap and get more information?
Well, I am in a fortunate position. I mean, so the fact that I am an analyst, people want to talk with me. So that's
you can talk to Enrico, everybody. You can do that.
So I have a lot of interviews with both users and vendors, and I connect the dots. So if I find many users wanting the same feature, and I check with the vendors if they are developing this kind of feature to understand if they are going to have a solution that makes sense for the majority of the users. That's the idea. In general, I am in touch with several communities, so just to still get an idea of what is really happening with practitioners, and that's it. I mean, I still informed with events, physical events when possible, when we will be able to travel again.
Yes.
Because I am an analyst again, I can talk with several people in the not only on the marketing side, but also on the engineering side, and what is happening in the development, the roadmap of the solution. So again, for me, it's probably different than many others. I suggest that community like this is one of the most important source of information today, much more than vendors, because of course the vendors has to sell the solution.
And you'll get a great video and a demo and all the stuff that you want about the product.
Yes, you have to talk with people that already implemented, that is somehow trying to make the same decision that you're trying to make. So and see with common sense why they're doing it and why not.
Mm-hmm. Very, very good. That being said, can I ask you to stop sharing your screen so I can share mine really quickly?
Yes, sure.
Okay. We have a tradition in our community that we always like to have a visual representation of things as we're finishing up. So I will, while we were talking, our wonderful graphic recorder, Angel, I think you can see my screen now. You should be able to. Can you see my screen? Good. So while we were talking, Angel created a graphic representation of all the different things that you touched on. Obviously, we would probably need 3 or 4 drawings to really show everything because there was a lot of things that were mentioned there. But I think it's a nice summary. And of course, we got a little bit of gelato in there. It's a very hot day. It sounds like a really nice thing to have. If only we can mix those things together. I think in the future, I would like to do another meetup with you, Enrico, and we could focus on how we can compare and contrast the gelato world to the world of data storage on Kubernetes.
We can. Of course, it's gelato. I mean, I have a lot of hobbies, not only gelato. As you saw in my in my bio. There is gelato, there is gin, which is another
Okay,
passion,
we can do
and
that too. We
cigars.
can do that. Yeah, we can do that. I don't think anyone's gonna have a problem with that. I think it would be a good way to petition to have a KubeCon or something celebrated in Rimini, so we can enjoy all the other things that are there, and we can also do a blind tasting for gin. That sounds great. Do you really quickly though? Do you have a favorite gin? Can I ask that?
Well, actually, I have many. It really depends on the occasion.
Yeah.
And so there is a gin that is produced in Tuscany
Okay.
now that I really enjoy it. Of course, most of my gin is about gin and tonic, but this particular one is something that I can drink also, raw without any other addition, and it's really
Wow.
really neat, good.
Okay.
I mean,
Go gin from Tuscany. I never really heard about bad things coming out of Tuscany when it
well,
comes to
no,
food
yes,
and
but
drink.
actually,
So
but actually, is an English guy, that moved to Tuscany, and because, of course, it was not, there was no gin like
yeah.
he wanted, like the one he wanted, so he started doing it.
Yeah. But I think and this happens with tons of businesses. Someone suffers from a problem, so they provide a solution to a problem that they previously had. So that's good. That's good. All right. Anyway, so there's plenty more that we can talk about. In terms of links and things like that, if somebody wants to get in touch with you, with your role as an analyst, the best way to do it is through Twitter, through LinkedIn. What's the
But
best way?
Twitter is easy. I'm not always there, but I'm listening on Twitter. So
Okay.
Signoretti is something that you can find me there, and LinkedIn, whatever, any social media. Probably I have an account of some.
Okay, very, very good.
Not
We still
TikTok,
didn't.
but
Oh, okay. Yeah, I'm not on TikTok yet either. We still have a couple of questions that we didn't get to, but we'll try to address those in Slack. Enrico, thank you so much for your time today. This was extremely informative. Thanks to everyone for participating. For the questions, really, really good stuff. And we have this week. We have 3 meetups. We'll have another meetup tomorrow with another Italian person by chance, Gabriele Bartolini from EDB. We'll be talking about Postgres, enterprise Kubernetes, and lots of other stuff there. So Enrico, once again, thank you very much for your time, and look
thank
forward to
you.
having you back with us soon.
Okay, bye bye.
All right, take care. Ciao.